LCM and HCF of fractions and numbers with decimal point. HCF of fractions. The formula is very simple. HCF of fractions is equal to HCF of the numerators divided by LCM of the denominators. LCM of the fractions is equal to LCM of the numerators divided by HCF of the denominators. An easy way to remember it is HCF. For finding the HCF comes in the numerator. For finding the LCM comes in the numerator. This is an easy way of remembering. HCF of 1 by 2, 5 by 3, 7 by 9. You know HCF of fractions is equal to HCF of numerators. So what are the numerators here? 1, 5, 7. So HCF will be equal to, HCF of numerators will be equal to 1 HCF of 1, 5, 7. Divided by LCM of denominators. So what are the denominators? 2, 3, 9. So LCM of 2, 3 and 9. HCM of 1, 5, 7 is equal to 1. LCM of 2, 3, 9 is 19. So the answer for this is 1 by 18. LCM of the same numbers. Let us try to find the LCM of same numbers. So the numerators are 1, 5, 7. So LCM of 1, 5, 7 divided by HCF of 2, 3, 9. LCM of 1, 5, 7 is 35. HCF of 2, 3, 9 is 1. Now we are going to find the HCF and LCM of decimal point numbers. Now the given numbers are 0.2, 0.05 and 0.0025. These are the given numbers. Now your objective is to eliminate the decimal point. How do you eliminate the decimal point? If you have a 0.2 and if you have to eliminate it, you have to multiply it by 10. Yes. So what I did here is I multiplied this by 10 and I multiplied this by 10 and I multiplied this by 10. So you multiply all these numbers by 10, you will get 2.5, 0.025. Now here it is eliminated. Here it is eliminated, but still point persists in the second and third terms, right? So how do you eliminate it? Again multiply it by 10. So you multiply again by 10, you will get 25.25. Again multiply it by 10, you will get 252.5. Again multiply it by 10, you will get 2525. And you take the HCF of 2525. The HCF of 2525 is 25, right? That is the HCF. Now, how many times did you multiply by 10? You did it 1 time, 2 times, 3 times, 4 times. So because you multiplied it by 10 4 times, what you have to do is, the final answer 25, you have to divide it by 4 zeros. Because you multiplied with 4 zeros, here was the first zero you multiplied with, here second zero, third zero, fourth zero. So because you multiplied it with 10,000, you have to divide the answer by 10,000 and your final answer will be 0.0025. Now to find the LCM, it is the same approach. 0.60 eliminated by multiplying. So this will end up 6.3. 0.63 will become 6.3. 6.3 will become 63. But still here we have decimal. So we have to still continue multiplying. So this will become 2.5 and now it will become 25. At this point you can try to find the LCM. Now if you try to find the LCM for 6,300, 525, you will get 3.15. The reason is the LCM of 6,300, 500 and 25 is 3, 1, 5, 0, 0. As we multiply this with 10,000, because this is the first 10, second 10, third 10, fourth 10. So 4 tens is 10,000. You have to divide it by 10,000. So if you divide this by 10,000, you will get 3.15 as your answer. If an integer k is divisible, now is the time to put your understanding to test. Also have a look at this. Did you know? Very important. If an integer k is divisible by 2, 5 and 13, what is the next largest number that is divisible by all the three given numbers? So these are the options. You can pause the video, try to solve it and then come back. Now an integer k is divisible by 2, 5 and 13. What is the next largest number that is divisible by all the three given numbers? I want you to cast your mind to this slide where we were seeing LCM, right? Here I told you 100, which is the LCM, is the first number divisible by both 25 and 20. Yes. So what is the next number divisible by both 25 and 20? It is 2 into LCM. Then third number is 3 into LCM. This is the exact principle that we are going to be applying to solve this problem. Now, to solve this problem, they've given k is divisible by 2, 5 and 13. So, if an integer k is divisible by 2, 5, 13, then we know that k is LCM. It could be LCM or 2 into LCM or 3 into LCM and so on, right? Yes. If it is divisible by 2, 5 and 13, k is divisible by 2, 5 and 13, then we know that there in that example in the previous slide, 100 was divisible by 20 and 25. So the next number that was divisible by 20 and 25 was 2 into 100, 200. The next number that was divisible by 20 and 25 was 3 into 100. Yes, I'll just make a point here. 20 and 25. 100 is the LCM. What is the next number? It is 200. What is the next number divisible by 20 and 25? It is 300. The next number is 400. So all these are LCM, 2 into LCM, 3 into LCM, 4 into LCM. Similarly, if k is the integer divisible by 2 and 5, 13, k could be any of these numbers. Yes, because all these numbers are divisible by 2, 5 and 13. Yes, so we are asked to find the next largest number succeeding k. The next largest number succeeding k. So, which is divisible by 2, 5 and 13. So, if k was LCM, the next largest number would be 2 into LCM. So, if k was 2 into LCM, the next largest number will be 3 into LCM. If k was 3 into LCM, the next largest number would be 4 into LCM, and it goes on infinitely. But the point you should understand is the difference between k and the next largest number will be LCM. Yes, guys. What is the difference between LCM and 2 into LCM? It is LCM, right? What is the difference between 2 into LCM and 3 into LCM? It is LCM, right? What is the difference between 3 into LCM and 4 into LCM? It is LCM, right? So that is why I write the difference between k and the next largest number will be LCM. Hence, the next largest number will be k plus LCM of 2, 5 and 13, because those are the three numbers we are concerned in this problem. So the LCM of 2, 5 and 13 is 130. So the answer is k plus 130. What is the smallest square number which is divisible by 2, 4, 5, 6 and 9? Smallest number divisible by 2, 4, 5, 6 and 9 is the LCM of 2, 4, 5, 6 and 9. Yes, it is the same thing. 100 in the previous example, 20 and 25, the smallest number divided by 20 and 25 was 100. Smallest number divided by 20 and 25 was 100. What was 100? 100 was the LCM of 20 and 25. So you have to remember this, which is LCM of two numbers is equal to smallest number divisible by those two numbers. So this, write it down somewhere, keep it, okay, take a screenshot. This is a very important thing that we will be using. So LCM of any two numbers will be the smallest number divisible by A and B. Similarly, the smallest number divisible by 2, 4, 5, 6 and 9 is the LCM of 2, 4, 5, 6 and 9. So here the LCM is 180. So we got the smallest number to be 180. But the question is not the smallest number, the question is smallest square number. Is 180 a square number? No, right? Square numbers are numbers which are multiples of the same number. For example, by square number, what they mean is 5 into 5 gives you 25. This is a square number. 17 into 17, 289. This is a square number. 25 into 25, 625. This is a square number. So 180 is not a square number. Even in chapters where we teach now square root of numbers, you will know how to remember square root of numbers, then this problem will become even easier. Second smallest number divisible by 2, 4, 6 and 9 is 180 plus LCM. Yes, just now we saw the difference between these two numbers will be equal to LCM. Yes, in the previous example. So 180 plus 180 will give you 360. What is the next number? It is 360 plus 180, which is 540. So the third smallest number will be equal to 540. So this is 180, right? So 180 plus 180 will give you 360. Now 360 plus 180 will give you 540. Fourth smallest number is 720. Guys, this goes on. But you need to find a perfect square. Now you know, by continuing like this, fifth or the first smallest square number divisible by is, you will arrive at 900. Now is 900 you all know is a perfect square, because 900 is nothing but 30 into 30. Find the sum of the first 50 common terms of 12, 16, 20 and 18, 24, 30. So here you are going to find the first 50 common terms of these two series. There are two series. First series is 12, 16, 20. Second series is 18, 24 and 30. Both the series are in arithmetic progression. But what you have to concentrate on is the common difference. The common difference in the first series is 4, right? The common difference in second series, what is the common difference in second series? It is 6. 24 minus 18 is 6. 30 minus 24 is 6. 16 minus 12 is 4. 20 minus 16 is 4. So the common difference between them are this. Now you have to find the common terms, the sum of the first 50 common terms of these two series. So let us take an example. What could be the first common term in this? If you have a look, here the difference is 4. Here the difference is 6. Common term is the term where this 4 and 6 meet, correct? Or in other words, it is the LCM of 4 and 6. Where do 4 and 6 meet? See, 4, 8, 12, 16, 20, 24, and so on like that. 6, 12, 18, 24, so on like that. Now, so this is the common difference, is what 6 means. So can you see that? But the series starts here 12, 16, 20, and here it starts here. For this one, it starts here. They have omitted these two things. Okay. Now you can see for this term, 12, for both these 12 are common, 24 are common. Yes. So you see 12 is common. So in that common series, first number will be 12. The second number will be 24. You can see what is the common difference. It is 12, right? The common difference is 12. The common difference of the common series is 12. Now how did this 12 come about? This 12 came about because this 12 is the LCM of 4 and 6. So the LCM of 4, 6 is 12. That is the reason why I wrote it like this. I wrote all the multiples of 4, I wrote all the multiples of 6, and I took the least common multiple. So this is 12 is the least common multiple of 4 and 6. So here this is the series 12, 24, 36, and the common difference is 12. Using that you can easily find the answer. So a series like this will be formed. This is because the LCM of 4 and 6 is 12. Actual series of common terms is 24. Because guys, you cannot start with 12. What is the reason? Because the second series starts with 18. So you cannot have this 12. So the actual series of common terms is 24. We have left out 12 because second series starts from 18. Now you can use the sum of AP formula to calculate the sum. So this is the formula. So in progressions, you will understand you will understand this clearly. The numbers 673 and 865 are divisible by which of the following, leaving a remainder 1? So this is the question. Just go through it. The numbers 673 and 865 are divisible by which of the following, leaving a remainder 1? Now the important thing guys you have to understand is 673 and 865, you are dividing this by some number. We don't know what this number is guys. We don't know what that number is. You are dividing 673 and 865. But when you divide it by that number, same number, for both 673 and 865, you are dividing it by a same number. When you divide it by a same number, you get 1 as the remainder. You get 1 as the remainder. Now what does it say? Both gives the same remainder 1. It means you subtract 1 from here and you subtract 1 from here. You will get two numbers, right? What can you say about these numbers? You can say these two numbers will give remainder 0 when you divide it by that number, that mystery number. When you divide it by that mystery number, these two will give remainder 0. Which number can divide this and give remainder 0? Can anybody think of it? I want to pause the video and think about it. Which number can divide 672 and 864 and give the remainder 0 and 0? So pause the video now. So I hope you got some answers. My question now is, I'm going to make this very simple. 12, comma, 15. 12 comma 15. 12 comma 16. Which number, if I divide, will give remainder 0 and 0? Yes, you divide by 2, you will get remainder 0 and 0, right? That is true. You divide by 4, you will get remainder 0 and 0. But I want the largest such number. I want the largest such number. Guys, largest such number is nothing but the HCF of 12 and 16. Yes, you can divide this by 1, you will get remainder 0. You can divide this by 12, you will get remainders 12 and 16. You can divide it by 4, you will get remainders 12 and 16. So this is actually 12 and 16. You take 4 out, you will get 3 comma 4. So this 4 that we are looking for is the HCF. So find the HCF of 672 and 864. Then you will get your answer. Okay, I thought the question was a little different, but this question is different. Okay, when they are given the options, you have to see what this is different. Okay, so let us take. So the same thing, 673 minus 1, 865 minus 1. They are given the options now. So you have to see, hence 672 and 864. If you see both these numbers are divisible by 2, 3 and 4. Okay, so if they give you only one option, then they ask you, then you take the highest common factor numbers divisible following remainder. You can take this. Okay, now they are not asking for HCF, guys. So that's what I thought this was a different question. Okay, in this question they are not talking about HCF. They are talking about what are the numbers which can divide and leave remainder 1. So you go back 1, you subtract 1, you will get the actual numbers divisible by 2, 3 and 4. So the actual number, which is 672 and 864, is divisible by 2, it is divisible by 3, and it is divisible by 4. Hence the answer is 2, 3 and 4. What are the largest 4-digit and smallest 3-digit numbers divisible by 6, 15, 21 and 24? In this case, the first thing that you have to do is find the first number divisible by them all. So the first number divisible by them are 6, 15, 21 and 24. 840. So the LCM of 6, 15, 21 and 24 are 840. The smallest 3-digit number divisible by 6, 15, 21 and 24 will be 840. So we got the smallest 3-digit. Right now we need largest 4-digit number. So what do we do? So bring this close to 10,000. Okay, so multiply it by 10. You get 8,400. 8,400 plus 840 will be 9,240. So this should be the largest 4-digit number. Because if you add one more 840 to this, your digits will become 5. Number of digits will go beyond 10,000. So this is the largest 4-digit number. Hence the answer is 9240 and 840. What is the least perfect square which is divisible by 24, 30 and 60? The least perfect square. So I want you to pause this video, guys, and try it out and then come back. Yes, I hope you got an answer. So for this, first you have to find the LCM of 24 and 30 and 60, because that is the first number divisible by 24, 30 and 60. So it comes to 120. Now the second number will be 240. The third number will be 360. The fourth number will be, it goes on like this, right? Now all these numbers, they are not square numbers. 480, 600, 720, 840, 360, they are not square numbers. Only when it comes to 3600 you can say it is square number, because 3600 is nothing but 60 into 60. So this is where your knowledge of square numbers and taking square roots will help you. So we have a separate course for that, so you can refer to that. This is a difficult problem. Now, so read the question carefully. What is the greatest common divisor, or in other words, they are asking HCF. What is the HCF? And they have also given the definition of HCF inside the brackets. Largest number that will divide both the numbers with remainder 0. I told you, right? If a number can divide two numbers and give you remainder 0, it could be HCF. Okay. And if it could be HCF because all common factors will do that. Common factors of both numbers will do that. But the HCF is the largest of those numbers. You remember the slide here? We'll just go back to this HCF slide. Do you remember this? Yes, 60 and 90 have many factors, but we had a few common factors. And among these common factors, the largest was 30. So we said the largest common factor or highest common factor is 30. Okay. Similar here, all these numbers 1, 2, 3, 5, 10, 15, 30, all these numbers will divide 60 and 90. If you pay close attention, all these numbers will divide 60 and 90 and give remainders 0. Okay, so that is the point I was trying to make. So here, in this example, that is what they say, the largest number that will divide both numbers with no remainder is HCF. Okay, so they given, you have to find the HCF of two numbers. This number is pretty large. Look at this number. If you look at this number, it is 111,27810 times. What it means is, this is 1, 2, 3, 4, 5, 6, like this. It goes on up until 27810 once. Okay, so you cannot write those ones, right? So that is why they have not written. Now in Y, 1, 2, 3, 4, 5, 6, 7, 8, and it goes on up until 1750 times. So there are 1750 ones in this number. There are 27,810 ones in this number. Now you have to find what is the HCF of these two numbers. That is what you are asked to find. Okay. Now these are the options. Now with the options you cannot come understand much. But what I want you guys to understand is, so pay close attention to this. Okay, this is a very difficult problem, but once you understand it, it is very easy. Now just look at this. Take 11 and divide it by 1. What do you get? You are able to completely divide 11. 11 by 11 is 11. There won't be any remainder. Here remainder is 0. Similarly, take a number with 4 ones and divide it by 1, 11 and 4 ones. Again, you will be able to divide it without a remainder. But if you divide 4 ones by 3 ones, you will get a remainder. But if you divide 4 ones with these numbers, you won't get a remainder. 6 ones. Divide 6 ones with these numbers, your remainder will be 0. 8 ones. Divide 8 ones with these numbers, your remainder will be 0. Guys, so what can you observe? Just observe this. So what you can observe here is, here you have, even this can divide. Okay, here you have 2 ones. Here the number 2. Here what are the, how many number of ones are there? 1 and 2. Here the number is 4. Here you have 1, 2, 4. So here you have 6. Here you have 1, 2, 3, 6. Here you have 8. So you have 1, 2, 4, 8. Yes, guys. So what you are able to see here is these are the multiples. These are the factors of those multiples. Right? Am I right? 8 is the multiple. 1, 2, 4, 8 are factors of the multiple 8. 6 is the multiple. 1, 2, 3, 6 are what? Factors of the multiple 6. 4 is the multiple. 1, 2, 4 is factors of 4. 2 is the multiple. 1, 2 are factors of 2. So this is one unique property that you find for numbers. So if everything is 1, this is one unique property that you will find. You can use a calculator and check it out later. Now that you understand this property, we can solve this problem. Okay. So when what are this 2, 4, 6, 8? All those are even numbers. Yes. So whenever you have even number of ones, it will be divided. What does this? What can you extract from this? It will be divided by all the numbers which have the number of ones equal to the factors of this number. The number of ones equal to factors. Okay. Here the number of ones will be equal to factor of 2, 1. The number of ones will be equal to factor of 2, 2. Here the number of ones will be equal to factor of 1, 4. Number of ones will be equal to factor of 4, 2. Here the number of ones will be equal to factor of 4, 4. Okay. So this is what you can understand from this, guys. So you, for us, the given two numbers are 27810 and 1750. Now what you do is you have to find the HCF of these two numbers. Yes, you have to find the HCF of 27810 and 1750. Highest common factor, because the HCF of these two numbers will give you the answer, right? If I asked you, okay. Okay, if let's take this example, okay, 4 and 6, okay, forget about 27810 and 1750 for a moment, guys. Now just look at this example 4 and 6, okay. Here there are 4 means we have 4 ones. This means we have 6 ones. I give you the same question. What is the highest common factor which will divide 4 and 6? Or what is the highest common factor, okay, which will divide the same number? What is the greatest common divisor of the following two numbers? What are the greatest common divisors of this and this? So what will I do? You guys know for 4, these are the factors 1, 2, 4. For 6, 1, 2, 3, 6 are the factors, right? So 4, it is 1, 2, 4 are the factors. For 6 it is 1, 2, 3, 6 are the factors. Guys, now you tell me from this, how do you find the HCF? These are the factors. These are the common factors. So the highest common factor is 2. So the number 2 indicates 2 ones. So this number divides this and this and gives a remainder of 0. That is the meaning. So in essence, what you did was you found the HCF of 4 and 6. That many number of ones is your answer. So that is what I am doing here also. I am finding the HCF of 27,810 and 1,750, so that many number of ones will be my answer. Yes. So I take 10 outside. This is one way of finding the HCF. You will get 2781 and 175, and you can write 2781 and take down its factors. Take factors of 175. So you can see the common factor. There is only one common factor. What is it? It is 1. So it should be the highest common factor. So I write 10 into 1. So your answer is 10. I write 10 into 1. So your answer is 10. So what does it mean? It is 1 10 times is the correct answer. how many numbers less than 500 are divisible by 12 and 18? So they are asking how many numbers less than 500 divisible by 12 and 18. The first thing, guys, is for you to find the first number divisible by 12 and 18. What is the first number divisible by 12 and 18? First number divisible by 12 and 18 is the LCM of 12 and 18. So the LCM of 12 and 18 is 36. So first number divisible by 12 and 18 is 36. Then the numbers less than 500 divisible by 12 and 18, you can do it by these are the numbers 36, 78, 108, 144, yes, so on and so forth. And you need not go like this. You can just divide 500 by 36, you will get the answer. So the final answer will be 13. Okay. Now, for example, this 500 by 36, what is happening is you are finding how many 36 are there in 500. For that, you are dividing 500 by 36. Now, I want to know how many 50s are there in, how many numbers less than 500 are divisible by 50. That is my question. How many numbers less than 500 are divisible by 50? So first number will be 50, second number will be 100, third number will be 150, fourth number will be 200. So to do this, instead of going like this, I can just do 500 by 50, which will give me 10. So like this, there will be 10 numbers. So that is what I am doing here. So instead of doing 500 by 50, instead of 50, we have 36 here. So we got 13 point something, which means it is 13. There will be 13 such complete numbers. We won't get 14 because it is not complete. Okay. The reciprocal of HCF and LCM of two numbers are 1 by 12 and 1 by 312 respectively. If one of the numbers is 24, find the other number. The reciprocal of HCF and LCM of two numbers are 1 by 12 and 1 by 312. So it means HCF is equal to 12. If reciprocal is 1 by 12, then HCF will be 12. If the reciprocal of LCM is 1 by 312, LCM will be 312, right? For two numbers, product of two numbers is equal to LCM into HCF. We've seen this formula already. Just go back in the video, you will find it. And you must make a note that it is for two numbers and two numbers only. Don't apply this formula for three numbers. For three numbers, I have also given you the formula to do it. Just refer to that and find. For three numbers, it is LCM into HCF square. Okay. For four numbers, it is LCM into HCF cube. Just refer to that formula. So first number we don't know. We have to find that into 24. 24 is given in the question. Will be equal to 312 into HCF. And from this, you can solve for the first number. So the final answer is 156. If LCM and HCF of two numbers are 234 and 13 respectively, then the smallest factor of the product of the two numbers is. Again, you can use the formula that we used in the previous question. LCM, they say is 234. It could be written as 13 into 3 into 3 into 2. HCF could be written as 13. Now, you know product of two numbers is equal to LCM into HCF. So, in the question, they want the smallest factor in the product of two numbers. So, you do product of two numbers is equal to 13 into 3 into 3 into 2 into 13. Now, the smallest factor here is 2. So, the answer is 2. Find the least 3-digit number which when divided by 5730 leaves same remainder 3 in each case. Find the least 3-digit number which when divided by 5, 7, 13 leaves same remainder 3 in each case. I have a question, guys. Okay, so you tell me, find the least number divided by 1, 2, 3. What is the answer? Least number divisible by 1, 2, 3. This is nothing but LCM of 1, 2, 3, right? This is nothing but LCM of 1, 2, 3. What is the LCM of 1, 2, 3? It is 6. So 6 is the least number which is divisible by 1, 2, 3. What does divisible by means? It means the remainder is 0. Yes, guys, it means the remainder is 0. Okay, now 1, 2, 3, let us take this one out. Okay, we don't need this one. Let's take 2, 3. So LCM of 2, 3 is 6. So the 6 is divisible by 2 and 3 gives you a remainder of 0. When 6 is divided by 2 and when 6 is divided by 3, it will give you a remainder of 0. Okay. Now, if I have to get a remainder of 1, when I divide by 2 and 3, guys, what should I do? I should just add 1 here, right? If I add 1, what will happen? This will become 7. Now divide this by 2, you will get a remainder of 1. Divide this by 3, you will get a remainder of 1. Yes. So what I did was, I found the LCM, added the remainder. Yes. The same thing I am going to do here. Find the LCM, add the remainder. Okay. So the least 3-digit number divisible by 5, 7, 13 is LCM of 5, 7 and 13, which is 455. And if I have to get a remainder of 3, I will add 3 to it. I will get 458. So 458 is the number which when divided by 5, 7 and 13 gives you a remainder of 3. It means divide 458 by 5, you will get 3. Divide 458 by 7, you will get 3. Divide 458 by 13, you will get 3. By 3, I mean remainder. Okay, the remainder will be 3. Find the least number which when divided by 5, 8 and 19 leaves remainders 2, 5 and 16 respectively. Now here the previous problem, the remainders you divided, you had 3 numbers but your remainders were not unique, they were the same. For this divisor your remainder was 3, for this divisor it was 3 and for this divisor also it was 3. Your remainders remain constant. But in this problem your remainder is not constant. For 5 your remainder is 2, for 8 your remainder is 5 and for 19 your remainder is 16. So in this case there is a different way of solving the problem. Guys, in all these problems you will always find 5 corresponds to 2, 8 corresponds to 5, 19 corresponds to 16. See what happens. The least 3-digit number divisible by 5, 8 and 19. First find that out and keep it. It is 760. Okay. So you can find the least 3-digit number. Now the next thing that you are going to do is difference between 5, 8 and 19 and remainders 2, 5 and 16 is equal to 3. Okay. So difference between 5, 8 and 19 and remainders 2, 5 and 16 respectively is equal to 3. Now why do I say it is 3? What is 5 minus 2, guys? What is 5 minus 2? 3. What is 8 minus 5? 3. What is 19 minus 16? 3. Okay. So all these problems, this difference between divisors and remainders will always be the same. So you need not worry about it being different. Always in this type of problems, the difference between divisors and the remainders will always be the same. Whenever you have a unique remainder for a divisor, then you will always find that the difference will be the same. But in the previous problem, we had the same remainder for all the divisors. But here, each divisor has its own remainder. In this case, the difference between them 5 minus 2, 8 minus 5, 19 minus 16 will always be the same. So take that 3, and what we are going to do is to get the answer, just simply subtract 760 and the 3. You will get 757. 757 is your final answer, guys. So if you now take 757 divided by 5, you will find that your remainder is 2. Take 757 divided by 8, you will find that your remainder is 5. Take 757 divided by 19, you will find that your remainder is 16. So this is how we solve this type. The largest measuring cylinder that can accurately fill 3 tanks of capacity 98, 182, 266 and 266 liters each. They are asking what is the largest measuring cylinder, okay, which can accurately fill. Now accurately fill. Now you have to accurately fill 98, 182, 166 liters. All these are in liters, right? You have to accurately fill. See, I can use a 1 liter cylinder and fill it, right? Yes, 1 liter cylinder, but I will need 98 cylinders. But I can use 1 liter cylinders, right? If I use 1 liter cylinders, I'll need 98 cylinders, here 182 cylinders, 166 cylinders. If I use 2 liter cylinders, what will happen? Still I can accurately fill it. Yes, 2 liter cylinders I can fill this, 2 liter cylinders I can fill this, 2 liter cylinders I can also fill this. But I'll need 49 2 liter cylinders, 91 2 liter cylinders. Oh, sorry, this is 266. So 133 2 liter cylinders. Now if I increase this to 7, so let's see if we can do 7. Okay, if I increase this to 7, now can we use 3 liters, guys, and fill this accurately? No, right? Using 3 liters you cannot fill this because 98 is not divisible by 3. Okay, so you are seeing that we are looking at the factors of these numbers. Yes, so when you are looking at the factors of these numbers, and especially when they ask the largest of such number, it means we are dealing with HCF, highest common factor. So just find the HCF of these numbers, you will get the answer. The largest measuring cylinder that can accurately fill 3 tanks of varying capacity, HCF of 98, 182 and 260. For 98, it is 7 into 7 into 2. 182 is 13 into 7 into 2. 260 is 19. So you will get HCF, remember, in prime factorization method is the smallest powers of common factors. So the common factors are 2 and 7. The smallest powers will give you 14. So the answer is 14. And thank you, guys.